Good afternoon, students. Am I audible? Hello, Akash. Hello, are you getting my voice? Just wait a few minutes, then we will start the session. Okay, so today we will discuss multiplexer and demultiplexer. Okay, and before going to start the multiplexer and demultiplexer, first in the last class we had discussed about BCD adder and BCD adder, and in that class, actually, I gave you a homework. Okay, so anyone did this homework? I told the process that after nine, the BCD conversion actually in binary from 0 to 9. Uh, there is no such differences for the case of binary and BCD, but after 9 there is a difference, or there is a need of correction. So due to this need of correction, actually what is the process I have told in the last class, and I wanted in the last class that from 10, what should be the BCD form, you just write in your copy. Anybody did this task? If anyone did this task, then I will give you permission to share your copy. I think no one has done his work. Okay. Just a minute, I am sharing the screen. I think now the picture is visible for all of you. It is visible.
Yes.
Okay, so here you can see that from 0 to 9, there is no difference uh, between the binary number and binary coded decimal or BCD number. But whenever we are coming the position number or the decimal number 10, so here you can see for the binary, it is 1010. So here actually it is 8421 rules. So this is 8 and plus 2. So for the case of binary, we are getting this is 1010. But for the case of BCD, here actually it is not following the 8421 rule. Actually, it is uh, actually for BCD, actually the we added six or uh, 0110 to get the correct form of BCD, and after that we are getting this result for 10. Okay, and you already know for each digit, there is a four value. So for this is for 10, so here this is 0, for 0 for this is 0000, and for 1 this is 000 and 1. And these things we already covered whenever we have studied the uh, binary coded decimal. I think it is clear for all of you.
यस
Okay.
सर, ये वाला तो बनाए थे
ये वाला तुम
लास्ट में,
हाँ बोलो कौन सा।
मतलब अनकरेक्टेड और करेक्टेड।
हाँ, अनकरेक्टेड यहाँ पर अनकरेक्टेड हम शो नहीं किए हैं। अनकरेक्टेड क्या होगा, अनकरेक्टेड हम लिख देंगे यहाँ पर जो 11 का होगा अनकरेक्टेड, तो ये लिखना होगा, लेकिन जो करेक्टेड फॉर्म यहाँ पर हम शो कर रहे हैं ये एक्चुअल करेक्टेड होगा। ठीक है।
ओके
Okay, so now today we will study that is the multiplexer and demultiplexer. Just give me 1 second to share the screen. Okay. Okay, so first we will study that is multiplexer, or in the short form of MUX. Okay, so the term multiplexer actually means many into one. Okay, many into one. And in the multiplexing actually is a process of transmitting the large number of information over a single line. I am here drawing you for the block diagram of multiplexing, and then we will discuss. So suppose this is the input signal. Okay, input, and here one thing, this is the select line or select signal. Suppose this is M, and one output. Always remember, for the marks, one output. This is multiplexer or marks. Okay, so here the multiplexer is always called the data collector, because it selects one of the many inputs and steers the information into the output. Okay, now one thing, always remember, the multiplexer has n number of input and the output is only one, and one single output line, and the selection of a particular input line is controlled by a set of selection lines. So this is the here the M selection lines, and this is in input lines. Okay, now what is the purpose of this selection line here? Actually, the selection lines decide the number of input lines of a particular multiplexer. Okay, so if the number of n input line is equal to the 2 to the power m, then m select lines are required to select one of the n input lines. Suppose to select one out of 4 input lines. Suppose we have 4 input lines. Okay, so 4 input lines we will compare into 2 to the power m. So 2 to the power m, so here what is the value of m? If we compare 4 equals to 2 to the power m, so
m is equal to 2.
2. So from here we can calculate that m equals to 2. So if the input line is 4, so our selection line or select line should be 2. Okay, in that manner. So this is, suppose this is 4 into 1 mark. Okay, suppose 4 into 1 mark means this 4 is for the input lines and the 4 input, and 1 is for the 1 output. Okay, so suppose here
output.
Suppose this is 1, 2, 3, and 4. So these 4 are the input lines, and 1 is the for the output. This is output, this is input, and for this input we actually need 2 select lines. It is clear? It is clear or not?
Yes, sir.
Suppose, so can you tell me now, for 8 into 8 is to 1 marks. What is the select line? How many
Three,
number
sir.
of 3? For 16 to the power 4 means 4, like that. Okay, so now here one thing, that first we will draw the 4:1 multiplexer. So for the case of 4:1 multiplexer, the logic symbol of 4:1 multiplexer. Okay, so first I will draw the, suppose there is 4 input. Suppose this is D0, D1, D2, and D3, and this is 2 select line. So this is suppose S0 and S1, and 1 output. Suppose this is Y. This is 4:1 marks. Okay, this is the logic symbol. So it has 4 input lines from it is D0 to D3, and one single output, that is Y, and 2 select line, that is S0 and S1, to select one of the 4 input lines. Okay, now I will draw the truth table. So here data select inputs, and another column is the here output. So what is the input here? What is the input here? Hello, are you getting my voice?
Yes, sir.
Input here is D0 to D3, and one thing, this S0 and S1 is the select line, or you can say the reference line, and based on the reference line we are selecting the input lines. Okay, now always remember, for the case of marks and demarks, always remember here, for input, for the case of truth table, we will select the select line, that is S0 and S1. Okay, so suppose here I am writing S1 and S0, and Y is the output. So two for the case of 2 select line, we will get 4 combination, that is 0 0 0 1 1 0 and 1 1. These are the 4 combination. Now correspondingly the here output is D0, D1, D2, and D3. Okay, so now this is the truth table for 4:1 multiplexer. Now the data output is Y. So, and the data input here, data input is D0. So for the case of D0, first Y equals to like that, D0 into S1 bar and S0 bar. Okay, next is D1 into S1 bar into S0. Next is D2 into S1 into S0 bar, and the last one is D3 into S1 into S0. Okay, so here we are getting the 4 terms actually. Now if the above terms is odd, so the final expression, because we have only the one, for the case of 4:1 marks, only one output, so the final expression is Y equals to D0 S1 bar S0 bar plus D1 S1 bar S0 plus D2 S1 S0 bar plus D3 S1 S0. This is the output expression for 4:1 marks. Is there any doubt?
No, sir.
Okay. So using this expression, the 4:1 marks can be implemented using the two NOT gates. Okay, and fourth 3-input AND gate and one 4-input OR gate. Okay, so now I will show you the logic diagram of 4:1 marks. Okay, so I am just so here to draw the logic diagram of 4:1 marks, first here you just follow how I am drawing this logic diagram. It is very easy. So suppose this is S1, this is S0. So, and you just saw just few minutes ago there is a bar and no bar. So for no bar we are using the NOT gate. So here okay, so now we have 4 input. So this is D0, D1, D2 and D3. Now so for the case of D0, actually the first expression that was D0 S1 bar and S0 bar. So this is S1 bar and X0 bar. So this is the another, this is S1 bar and this is S0 bar. Now the second expression, that is D1 S1 bar S0. So this is D1 S1 bar and S0. This is S0. The third one expression was D2 S1 S0 bar. So this is D2. Next is S1 and S0 bar. And the last one, the expression was D3 S1 S0. So this is D3. This is S1 and this is S0. So we're just labeling. Okay. So first here, so this is AND gate. Multiplication was there, so AND gate. Okay. And This is the output. So this is the logic diagram of 4:1 mark. Is there any doubt?
No, sir.
Who said no, sir? Akash.
Anjan, sir.
Anjan. Anjan. At this moment, there is 16 students, and I am getting only one response. बाकी सारा को आ रहा है जो हम बोल रहे मार्क्स के
Yes, sir.
concept?
Yes, sir.
So with the help of two NOT gates, so here you can see this is the two NOT gate, and 4 3 input AND gate. This is the 4 3 input AND gate, and 1 4 input OR gate. We can easily build the 4:1 marks. Okay. Now this is the 4:1 marks. So now for the case of 8:1 marks, I am not drawing here. I will show you the 8:1 marks diagram actually. Okay. So just 1 minute. Just give me a few seconds to share. And one thing I forgot to mention that no, it's fine. Okay. So I think now you are watching the 8:1 marks. The screen is visible for all of you. Yes or no?
Yes.
Okay. So this is a
Yes, sir.
okay. So this is a 8:1 marks. 8:1 marks means there is 8 input lines, input data lines, and 3 select lines. Okay, 3 select lines. Here you can see the 8 data lines, that is D0 to D7, and 3 select line, that is S0, S1, and S2, and here again one output, that is Y. But one thing, it has also an enable output, enable input. So here you can see E for the enable input. Okay, so enable input, sometimes you will get E or E bar. Okay, so actually it provides both the normal and inverted outputs. Okay, Y and Y bar. Now when E equals to 0 or E bar equals to 0 or E bar equals to, just 1 minute. When E equals to 0 or E bar equals to 1, in that sense the multiplexer is divisible. Okay, but when the E equals to 1 or E bar equals to 0, then the select input, that is S0, S1, and S2 will select one of the data input to pass through the output. Okay, and the logic symbol, this is a logic symbol, and for 8:1 marks, IC number is here I am just 1 minute. IC number is IC 74151. This is a IC number for 8:1 marks. Okay, so here you can see for the truth table there is 3 select line, that is S0, S1 and S2, and I have said that enable inputs actually provide the normal and inverted. So here actually we are considering E equals to 0. So in that sense, the multiplexer is disabled. You can see here, and the rest of the point here E equals to 1. So we are getting the result, or you can say the multiplexer is enabled. Okay. So this is the truth table or the logic symbol of IC 74151. Okay. Now the thing I will share here, the logic diagram of IC 741 or 8:1 multiplexer. Okay, so we are getting the picture. Yes or no?
Yes.
Just 1 minute. I'm trying to zoom in for better visibility. Just 1 minute. Okay, so here you can see this is a 3 select line. This is S0 and this is S1 and this is S2. Okay, and these are the input data lines, that is D0 to D7, D0 to D7 here, and one enable input. Okay, so and after that we are actually getting the output here. So this is the logic diagram of IC 74151, and with the help of here that is the 4 input 8 AND gates and 4 I think 7 NOT gates and the OR gate, it is there. So with the help of, we can easily construct the 8:1 multiplexer. So is there any doubt for 8:1 multiplexer? Is there any doubt? Hello?
Sir, what about
No,
enable?
sir.
Yeah, what about enable? Yes. Screen. Yeah, what about enable? So actually enable is a input. This is only in for the case of 8:1 and 8:1 marks. Okay, and actually it provides the both the normal and inverted outputs. So here actually you can see, just 1 minute, I am trying to zoom in this figure. So here you can see in the case of output, there is y and y bar. I think you are getting y and y bar. It is visible.
Yes, sir.
Yes, sir.
Okay, so actually mm, enable actually that provides the both the normal and inverted. So here this is the normal version and this is the inverted output. Okay, so these the things, and that's why the enable is for the case of 8:1 multiplexer. Okay, so, but in the case of 4:1 multiplexer, you can see only there is y in the case of output, but here you can see for the case of 8:1 multiplexer, there is inverted as well as the normal output. That's why the actually it provides by the enable. Okay, it is clear now. With the help of
Yes, sir.
enable, we are actually getting the normal output as well as the inverted output. Okay, so your home task is that in this class we have seen that the 4:1 marks and 8:1 marks. So your home task is that to draw the logic symbol of 16:1 marks, as well as to draw the logic diagram of 16:1 marks in your copy. And today I will give you the assignment in the Google Classroom, and I will set a time limit. Within the time limit, you just submit your copy. Okay, that's all, nothing else. And okay, so the time is almost over. So in the next class we will discuss the demarks. Okay, so the marks portion is over. So in the next class we will discuss the demarks. So thank you for all of the participants for joining in this session. Thank you all. And one thing I have forgot to mention, and just only 1 minute left, and all of the participants write your name in the chat box for the attendance. Hurry up. Okay, so now I am ending this session. Thank you.